Hello everyone. In this video I am going to solve numerical questions from the chapter alternating current. So let us start with the first question. Here we have a pure inductor of inductance 25 millihenry which is connected to a source of 220 volts. Find the inductive reactance. You need to find inductive reactance and RMS value of current in the circuit if the frequency is 50 Hz. First, let me write the data. Data given is a pure inductor is connected to an AC source. Here there is an inductor and AC source here. Okay, so now the value of inductance is L is equal to 25 millihenry and source voltage, if it is not mentioned whether it is peak value, RMS value or average value, you should take it as RMS value only. VRMS is 220 volts and then frequency of AC source is given, that is 50 Hz. So what do you need to find? To find inductive reactance, that is XL is equal to how much, and RMS current, that is IRMS, how much. So now let us find inductive reactance first. XL is equal to L omega is the formula for inductive reactance, that is equal to L into omega is 2 pi f. So that is equal to L is 25 into 10 to the power minus 3 into 2 into pi is 3.14, f is 50. If you multiply this, you might get the value of XL as 7.85 ohms. Next we have RMS value of current, that is IRMS, which is equal to VRMS divided by XL. VRMS is 220 volts and XL value just now we have calculated, that is 7.85 ohms. So if you divide that, you will get around 28 ampere. Therefore, our final answers are XL is equal to 7.85 ohms and IRMS is equal to 28 ampere. So now let us move to the next numerical. The question is, an inductor and a bulb are connected in series to an AC source of 220 volts 50 Hz. A current of 11 ampere flows in the circuit and the phase difference between the voltage and current is pi by 4 radians. Calculate impedance and inductance of the circuit. So let me write the data first. Here we have an inductor and a bulb are connected in series with the AC source. So here we have an inductor and a bulb. So here Vrms is 220 volts, frequency is 50 hertz, Irms is 11 ampere, phase difference is given, phi is equal to pi by 4 radians. So we need to calculate the impedance. So impedance first is given by using this data we have to calculate impedance, means we can use V by I or Vrms by Irms. Vrms is 220 volts, Irms is 11 ampere, that is equal to 20 ohms. This is the impedance. Next, we know that tan phi is equal to XL divided by R, that is equal to L omega divided by R, that is equal to L into 2 pi f divided by R. Here we need to find out L value, therefore L is equal to R into tan phi divided by 2 pi f. So that is equal to R value is, I think it is given, bulb. So R value we need to calculate. So here we can use another formula, that is cos phi is equal to R by Z. So from this R is equal to Z cos phi. So R is equal to Z is 20, cos phi value is 45 degree, that is 1 by root 2. So R value will be this value, directly you can substitute 20 divided by 1.414. So if I substitute that here, what do I get? That is equal to tan 45 is 1, so R value is 20 divided by root 2 is 1.414 into 2 into 3.14 into 50. So from we get L is equal to 0.045 Henry. Therefore inductance is 0.045 Henry and impedance is Z is equal to 20 ohms. So these are the values we had to calculate, which is expected in the question paper. So we'll move on to the next question, where we have a sinusoidal voltage of peak value 283 volt, frequency 50 Hz is applied to series LCR circuit in which R value, L value and C value are given. So we need to find many questions here, many sub questions are there, A, B, C, D like that. Question A is impedance of the circuit. Second one is the phase difference between the voltage across the source and the current. C is cos phi, that is power factor. And last one is the average power dissipated in the circuit. So let me write the data first. Here peak value is given, that is 283 volts, and the frequency is 50 hertz. Is applied in series LCR circuit. So inductor, resistor and a capacitor connected in series, so which is connected to AC source. L, C, R. L, C, R. Now R value is given, that is 3 ohm. L value 25.48 millihenry, and a capacitance of 796 microfarad. Here first one, that is impedance, is how much? We need to find out. Z is equal to how much? Second thing is phase difference, phi value we need to find out. C, power factor, that is cos phi. And last one is average power dissipated. Okay, average power dissipated. To find out impedance, we need XL value and XC values. First we'll find that. XL is equal to L omega, that is equal to L into 2 pi F. L is inductance, that is given here, 25.48 millihenry, 2 into 3.14 into 50 hertz. So XL is equal to, you will get around 7.99. I will write 8 ohms. So then we will find XC also is 1 divided by C omega, that is 1 divided by 2 pi F into C, that is 1 divided by 2 into 3.14 into 50 into 796 microfarad. So XC is equal to, you will get somewhere around 4 ohms. So from this you need to find out Z value. So Z value will become R square plus XL minus XC whole square. So that is equal to square root of R value is 3 square plus XL minus XC is 8 minus 4, which is 4. 4 4 is 16 you will get. So 16 plus 9 is 25. Square root of 25 is 5, which is in ohms. So next we need to find out question B. For that you can use the power factor formula, or first we can find out power factor and find phi. So we'll get phi is equal to tan inverse XL minus XC by R. So XL minus XC divided by R will give you 4 by 3. 4 by tan inverse 4 by 3 is 53.13 degree. Next we have question C, that is power factor cos phi is equal to R by Z. R is 3 divided by Z is 5. So we'll get 0.6. The average power dissipated is given by Vrms into Irms into power factor cos phi. Since Irms is not given, Vrms is also not given, I will take V0 by root 2. Irms can be given by V0 by root 2 into Z, which is into cos phi. So if you substitute the values of Z, cos phi and V0, so you will get the value of average power dissipated, that is 4800 watt. Okay, so this is the answer for this question. So consider this question as your homework question. Try to send the answer in the